Yes. We are now in STEM 2. I welcome everybody on board. We are now in STEM 2. STEM 2. In STEM 1, we have a question from Mr. Christopher. From Mr. Christopher. The question from Mr. Christopher is STEM 1. Now we are talking about the adapter and a DC card. So Mr. Christopher said, he asked a question. He said, how many voltages in pin? Mr. Christopher said, how many volts is in pin? Is the in pin? Yeah, the answer is 3 volts. So the 3 volts is coming out from the in pin, and it depends the adapter, and it depends the system. And the motherboard, you can regulate it, depend the voltage that will generate from the adapter to the system. The correct answer is SA is 1 point. That's 1 point, 1 volts, 1 volts. That's plus, minus. Or let's say 3 volts. The correct answer is 3 volts plus or minus. So in some cases, you will find adapter that will supply 3 voltage, while some adapter will supply below. But in the in pin, let me bring out the example of what I'm saying. This is the HP adapter. This one will be minus. Why this one is plus? And why this one will be plus, minus? The reason is that this one is the negative. Why this one is the plus, the 19 volts. This one to what? 3 volts. Here is the HP adapter. Everything. In this charging port here, there is a pin, and here, this one is 3, this one is one, 2, 3, 3 red, blue plus, and the minus is 3, 3. We have got brown. We have one, and what's here? One yellow, one yellow. This one is red, red. That's another line. Next three line here. So this pin is control the LED light. Right here, the pin here. Here's one LED. Here's another one. Which is for this. Another one for this. Another one for this. And this one for this. And this one for this. And this pin. So this, in this case is here, we have how many wires? 1, 2, 3, which is the minus, the negative. Here for the LED, this is white LED. This is the white LED. This one is the orange. Find this. 1, 2, 3, 4 plus. This one is 3 plus. This one is for power. This one for charging. So this voltage here is 3 volts. In some cases, let's say in adapter, in HP adapter, this voltage here, if you read only the charger may give you, let's say 4 volts, it may give you 9 volts and or 3 volts. Immediately you plug it to the laptop board, the voltage will regulate to the 3 volts. Some you see, the voltage will start from. You can see another system, maybe Dell, Lenovo. You can see, let's say 1 volt, 3 volts, 4 volts, and etc. So that is why the voltage here, the correct answer is, let's say, for 1 volt plus, it will count up. With the same mind, less. You can also spam less than 1 voltage. But the best thing, is 3 volts. It depends the adapter and it depends the system motherboard. So it depends of the charger that you plug, that will regulate and show you the voltage of what 3 volts plug or less than 3 volts. So that is the function of this intake. The intake. So this answer to correct from the step 1. A question from step 1. So there is it now. So now we start from step 2, which is our today's topic. Here is the motherboard. In this motherboard, this ENSA motherboard, This is that the step you take before you walk into the motherboard. Firstly, you have your DC chart. You calculate from your DC chart. You check the voltage. You are across from this DC chart to the motherboard. This is the DC chart for ASA motherboard. Here you go. This is that for ASA. Here we have 2 wires for red and 2 wires for black. These two join together because they have what is it, connector. These two together. Remember, like this, like this. You see this? Now this one is the minor, while this one is the plus. Red. Why this one is? From a DC jack, you can see with the cable going to the motherboard. Now the step you will take care from here is that on this board, before the board can be functioning, you have to check if the voltage is going inside the board. There is a step you will take before you go further inside the motherboard. What are the steps? There is some board protector. There is a thing that protects motherboard in case of the high voltage or if the anything that will damage the board, because the board is designed for 19 volts. As for this board, this ASA board, it's designed as the 19 volts. Then if you want to make use of any charger, your charger has to be a 19 volts charger. So 19 volts or above. The above is more than, no more than, let's say, 19.5 or 20 volts. So the step you take here is that before you go into the inside the board, so far, there is a board protector. What are the board protectors? And what are the things that you need to protect the board? And the IC that supplies voltage go inside the main programming chip and other power chip. So the things we take here is in this step 2. In step 2, first thing, we have, let's start from in step 2. The first thing you have to cross check is board protector. Board protector, because we need a board protector, because when you plug a high voltage or if any damage currently is coming from your adapter, the board protector has to receive it, or you have to block it, or to protect the board from anything damaging or things that will cause a serious damage to the motherboard. So we need this first. What are the board protectors? What are the board protectors? Yet now, the first thing we take here is first thing we list of board protector. One, the first thing we have in list of board protectors. One, we have a is Zener diode. 2, we have 3. Here we have fuse. These are the things that will protect the motherboard, because when the voltage go in, before the anything inside, in case when there is a damage coming, or if the voltage is coming, or if anything that will affect motherboard, these things can easily damage, or it can block the voltage. This is the first thing that can easily damage, to block the flow of the high current coming into the board, to protect the board from it. So here is the step you will take from this Zener diode for protector, and this capacitor for protector, and this. But we have to understand what we call Zener diode. Also understand what we call the capacitors. And fuse. The fuse, let me just bring out. Zener diode are widely used. Voltage reference. And as shuttle regulator. So, regulator to regulate the voltage. What? Across so Zener diodes are widely used as voltage reference and as short regulators to regulate the voltage across the small circuits. So this is another small example of it. Another small sample of it is what? To shape waveform. To shape waveform or provide protection. So right now, Zener diodes are widely used as voltage reference and as shock regulators to regulate the voltage across the small cycle, to shape the waveform or provide protection. So the reason why the Zener diodes have to protect, because the Zener diodes are designed, because their design is depending on the voltage of the thing that make use of. So Zener diodes can be, let's assume this motherboard is using 19 volts. Then the Zener diode is designed either 19.5 or more than 90 volts or 20 volts or 20 something volts. So because this board, the voltage into the board is 19 volts. So this Zener diode, it have to be 19 volts, let's say 19.5 plus. It have to be 19 volts plus 5 plus. So let's say the voltage limit stop. Let's 19 volts, 19 volts to 20 volts. Let's say 20 volts. Let's assume of, let's say 24 volts. So either the Zener diode is designed for 19.5, 20 volts or 24 volts, because this Zener diode is here to protect the motherboard in case you plug any voltage that above 19 volts. Because the body is designed, the IC, the power IC, the power cycle that on inside the board are only to use 19 volts, or it's no more, you have to use more than 20 to 24 volts. So because of that, the Zener diode have to be protect all the whole cycle inside the motherboard, because the cycle that is inside the motherboard is, let's assume, is 19 volts to be used, or 20 volts or 20 something volts to be used. So the Zener diode have to stop. The Zener diode, they have to be self-regulate to this voltage or regulate to this voltage, because the board have more is only used, is only designed for 20 volt plus. And the second thing is that we talk about capacitor. Yeah, the capacitor is an electronic the electric component that electric charge. So capacitor also can also be used as a board protector, because the value of that capacitor, it can also be used as maybe the voltage to go into the motherboard. Maybe it's 19 volts or 20 volts, or it must not above more than 19 volts. If the board is designed for 19 volts, so the capacitor can still be above, little above than 19 volts. Either it's 19 volts, 19.5, either it's 19 volts, 19.5, 20 volts, 20 volts, let's say 24 volts, etc. So the capacitor being a protector, it has to be between 19 to 24 volts. All the value of the voltage that will go into the board, so it must not more than this the voltage of this 24 volts. So to the capacitor. So any voltage that goes above this or above this, if the board is designed to use 19 volts, if the board is designed to use 20 volts, the capacitor will be equivalent to it, so that if the voltage goes inside, the board will be able to protect it. So the next is fuse. Fuse also used. Fuse also used as what? It's a board protector. So fuse also is a board protector. It's just like something like if any damage is coming past through from the charger into the motherboard, fuse can use it to protect it. All this is supposed to be in short explanation so that we can move fast forward. So The step you will take here from this motherboard, the first steps, the first things that will go into the motherboard with this board diagram. So what I will try to say that the board layers is designed, let's say in 3 layers. This is one layer, this is the second layer at the back, and the middle one. Because the line, you can move from this point, go to the middle point, and link to the other point. That is the 3 layers. So board is designed with 3 layers. So the first step you take, here is, so these 4 steps. This is that. The plus and the minus, which is the negative. Every open places inside the motherboard is negative. This iron you see here is negative. This you see here, all these open places you see inside this motherboard is a negative. So the first step is things that pass current into the motherboard. What do you see first? The chip is like this. The chip you first see this, let's say this minus and this is plus. This plus and minus is either that you have to negate. This is Zena. This is what will be the minus. Let's say this board is 19 volts. So the data may be between 19 to 20, let's say 24 volts. Or to protect, it can be 20 volts also. Just a sample. This data here, it will be what? 20 volts. So it is a voltage that above 19 volts comes to this will damage. This data will damage. This 90 volts. If the voltage above 20 volts comes to this inner diamond, it will do what? It will damage. And if people will continue again, let us protector, what protector? So let us capacitor. So in this capacitor now, if this capacitor is sitting on the negative and the positive, the minus and the plus. Now this is the plus and this is the minus. In this capacitor, is the voltage that will be in protector. It has to be from 90 volts. Here is 20 volts. So the voltage that will go inside, it has to be 90 volts, and the positive, you can see 90 volts, positive and minus. It has to be 20 volts or above to 24 volts. So if the voltage that is coming in is above to this one, this will do what? It will damage. So it will damage. So anybody that coming in, it have to be exactly to this value. It have to be below. Coming in, it have to be minus. Cannot be, it have to be minus down. This also it has to be minus down. So it must not above this. Above this, power supply. A power supply above Zener diode, above Zener or capacitor will damage these two chips. You understand now? So these things are both protector. Now continue to this stage. We have found something like a fuse. We say fuse. This is the way fuse is. Fuse is in this way. Now continue like this. Now fuse it this way. So fuse it this way. This is not concerned with. But here, there may be a two fuse, there may be a one fuse. If fuse is two, either it is at the end or it may be at the beginning here. That's mean the fuse is at the beginning. If this damage, if above voltage come to this diode, it can affect the fuse. Either it break or cut the fuse. If this here, if any damage comes here, it will not affect the fuse. The fuse will not worry. You cut the fuse, any voltage you take in, the fuse will receive it. If it's 90 volts, the fuse will receive the 90 volts and pass out the. Once the function of the fuse will be receiving and pass the voltage. That's what confused. Fuse receive and pass out a current. If you receive the current, you pass out the current. But if they damage here, the reason why they fuse, it protects the board from any damage or any putting. Once this one cannot receive the current or even this one damage, this will pass to this, and this one will go and be cut off. Now, the second step is here we have a chip. The chip that will receive all the I call it a cross chip, or is a fuse chip or diode chip. Let me check the rest of the stage. The first chip. This first chip. That will receive they are just like cross chip. Are just like it. The first chip that we receive the current, that will receive the current. What? Let's say uh, cross chip. Let's say the fuse. Let's say how we design it. So you just like this way. Take this. So this chip I was 4 leg like this. And then there is a fuse protector. Also there are also fuse in second places. Fuse is there, and this is the second fuse protector. Here is what? Here is the line. Here is the line. We have this. And this one goes. This one already. This minus spread. This very good. Then this go. This zeta for protector. Some God have this, why some doesn't have at all. So here as in there is zeta. The zeta is there. There's USB code. Let's go straight to this. So here we have how many pins? 4 pins. See? Here's another one. Like this, and like this. And after this click again. This will be our position of the set. See that? Cross key. These two. Because the voltage will go in, the voltage will also pass out. Let us assume this is the 19 volts going in. This is 19 volts. This will cross from here to here, 19. This will cross from here to here, here to here, which is 19. From this BC, let me use it. So this will pass. So the flow. So in this area, this black is not going there. It is only this line, only red line, only positive. It's not going with negative. This chip, we work as a diode, or you also working as like a fuse, because it has a polarity. The polarity on the back side and the front side. If you put the back side to the front side, it may not work, and it may work. Because all these IC, they have a different kind of number, and they have a list of number. But for you, if this chip damaged and you want to replace it from one board to another board, you have to sense the position of this IC already is. Then you take from that place and put it there. Because if you follow the number in another board, you will find another different number. This number that is there now is a P word, P4407. So, and this P4407, and in another board, you may see a different number. You may see P440112, or you may see IOR and a different type of number. So, and in this case, you will find a different kind of number. But if you understand the position, just take from one position and replace it into another position. That's what you have to do. Let's me how is that we have what? Our design here. This comes to this end. This comes to this. This join together. And this one join together. This one together, and this together. Do you see that? 3 legs together, and 4 chip legs together. This one are together, and this one are. But the chip is just sitting a different way, but the leg are like this. If the voltage on, it will go from here to here, and from here to everywhere. This second step 2. So I would like you to go into this board is ASA motherboard. If you have this ASA motherboard, then you follow up with this second step and the top 10, let's say from the first step to the second step and to the third step. And the continuous step is for you to understand all the function and the way the motherboard is working, how the voltage goes inside, and the other IC and the other spider IC, their function and what they are working for. The voltage, the output voltage supply from different chips. So in this first step, go and diagnose this and try and find this kind of board for you to understand this template. But if you don't have this board, any other system you have, you can also follow this template. From the voltage, from the positive line, you will find this kind of things. Diffuse, diode, or capacitor. You will see all these kind of things. In this particular area, you will find what? You will find your capacitor for protector. Like here now, you will find your capacitor, protector. This can go with this. This is not touching each other. But if you want to know, this one is 1, 2, 3 minimum, 1, 2, 3. All these eyes they have position. The position will be here, and this one is here. You see the position, the polarity. So here, if you want to run all this more, this like this. Let's go to this. You can go to this. Why this go to this? You see this major one, you're also supposed to push out the flow of this current to go inside. So this is how everything goes on. You have to understand it first. The Zener, or C. So this one also protecting. He is protector. He is a capacitor. This one is Zener, also our capacitor. Zener or capacitor, you're also protecting. So this is the fuse that will protect your body. This the protein will come from this to here. This cross with this, and this one cross with this, be crossing out. The position here is their position. So the second splice will not go so far. For you to understand that, once you plug a charger from the DC jack, the voltage will flow from the fuse, your protector, and from this and this, which is to come to this. In this second fuse in, you have to go like this too. Then to this one go. So the first fuse to protect any protein that happens. Let's see. So is to protect from this Zener direct. This way is to protect. With any cycle above this, the first fuse is to protect any above voltage coming from the Zener diode, which is the first work for this. So the second fuse
Wait. I'm able to copy it.
the second fuse is to prevent any above voltage or from to play from the board to protect from board. So why this and this? The fourth fuse is to protect any above voltage damage from the Zener diode. While the second fuse is to protect where the is the second fuse is to protect any above voltage or damage damage from the from the board. So this one is a protector. This one is also a protector. Then the cross chip. This cross chip is to pass the voltage going inside. The chip also always usually having 4 pin outside and 4 pin outside. If you count the pin, that is 1, 2, 3, 4. 1, 2, 3, 4. 8 pin. 8 pin chip. This one is 8 pin. This one is 8 pin chip. So I cross this together because this one and this one and this one are joined together. This one and this and this and this are joined together. This one and this is joined together. This one and this are joined together. That's the first chip you will come across before you go into the board. So all this cycle diagram you find here, all this is the first thing you pass through before you go in deep inside the motherboard. So the next step is we go into the power IC because this is chip that will supply the voltage into the board. So immediately the motherboard will receive the current. The second thing that will receive is the charging IC. And the charging IC. Why is the charging IC we go as the third steps? Because the adapter and the battery, they are the one that power the motherboard. Because when the adapter is present, when the charger is present to supply voltage in, the laptop will power on. When adapter is absent, the battery will supply in, then the battery will be able to power the laptop. So the first thing they have to go to the battery. So because adapter can power the laptop and the battery can power the laptop. So before we continue, the first thing, then we go into the battery. So that are the two power supply that power the motherboard. So before we break down to the charging, the power IC and the other chip that supply into the motherboard. So the second step will stop there. Why the third step? So I will continue the explanation. So thank you. Here is the voltage from the adapter. Here is 19 volts. Firstly, the pin inside here, you can see the straight line from the positive, the negative, every open places is negative. Every open places. So the negative already spread everywhere. So the negative line everywhere. This is the first fuse from the positive to this, which is the straight line from the positive. The plus going to this fuse, cross to the fuse. move down to here. The first chip. This chip cross the voltage from here to here. Cross voltage to here to here. And cross to this place. Cross voltage from this place to this place. And like this to here. So this is the second fuse. They make use of SMNT resistor. Now let's check the voltage like going inside here. From the first cross, there is a voltage coming from the adapter, the first cross chip. See here, cross to the 18 volts, cross to this place, same voltage. Now cross to this place. You can use any open space to check. You can position it to any places to give the same value. Any places, any open space, is negative. Every open space is negative. Every open space is negative. Every open space is what is negative. So just put your negative, the black wire, the black multimeter pin to the open space, and use the plus to check. You see the voltage coming flow from the adapter to this place. Flow to this place. Flow to this place. And to second pin. So the pin here is 1, 2, 3, and 4. They are together. This is another one then. To here. Here is the last pin, 1855. While the 3 pins that join together is 1861. Here is another 1, 2, 3, 4, 1861. Now there is a fuse here. The voltage that join here to the fuse. You see that the voltage that cross from this cross chip, it cross to this, to the fuse, and the fuse pass out to everywhere, every open space inside the motherboard. 1861, 1861, 1861. To move it to every open spaces. So in the next step, we are going to into the charging. After we treat the charging, then we go into other states.